What is linear regression modeling? Fundamentally, linear regression modeling is used to understand the relationship between variables within a data set. The simplest relationship that data inputs and outputs can have is a straight line taking the form y equals mx plus b. Linear regression modeling attempts to find a line that best fits those data points, with beta 1 representing the slope and beta naught being the y-intercept. In order to manually calculate a regression line, you would need to have the mean values of variables x and y, the standard deviation values of x and y, and the correlation value between x and y. Then you can find the slope of the regression line by dividing the standard deviation of y with the standard deviation of x and multiplying by correlation value r. After finding the slope, you can then rearrange the equation to find the y-intercept by plugging in the mean value of x, the mean value of y, and the slope. Linear regression modeling is excellent for data forecasting and portraying how strongly an independent variable will affect a dependent variable. By comparing a couple of variables and forming a regression line, we can therefore infer and predict how those variables will change in the future. However, simple linear regression modeling is limited in the sense where if you include more variables, then this method becomes unreliable and the regression line becomes impossible to form. Then a more complex method called multivariable linear regression modeling is used. Here is a study that utilizes the multivariable linear regression technique to model productivity construction in Iraq. Multiple tables are shown here that display the variables taken into account for the modeling. In this chart, we see a regression line and the coefficient of correlation, which helps us to understand the comparison of productivity and to predict the productivity of marble finishing works for floors. They concluded that this method has the ability to predict the productivity for finishing works with excellent degree of accuracy of the coefficient of correlation R is equal to 90.6% and the average accuracy percentage of 96.3%, and that there was a decent relationship between variables. Furthermore, they stated that the predicted values from the forecast model fit with real-life data. This concludes my presentation on linear regression modeling.